Hello, welcome back. So now in this we will continue our discussion. In the previous part we were discussing about the IS code provision and we have discussed about the equivalent shear force and bending moment. So now in the third step we will see what are the basic requirements of the reinforcement. So once we provide the reinforcement, we also need to check that they are satisfying the basic requirements of reinforcement as per IS code. So referring to this clause, we will now see what are the basic requirements of the reinforcement. Now, first requirement is based on the tension reinforcement. So the reinforcement that we provide as a tension reinforcement, it should satisfy some requirements such as the amount of minimum area of tension reinforcement. So IS code recommends that whatever area you provide, it should be more than the minimum area recommended by the IS code. Now, minimum area of reinforcement can be calculated by this relation. So this formula you can access from this clause. And in this AS is the minimum area of cross section, B and D is the breadth and effective depth of beam, and Fy is the characteristic strength. Similarly, we have maximum area of tension reinforcement limit also. So IS code recommends that maximum area of tension reinforcement shall not exceed 4% of the total cross-sectional area of beam. So total cross-sectional dimension is B and D, and 0.004 is 4%. So 0.04 times of BD, this is the amount our area should not exceed with this. Then we have requirements for compression reinforcement also. So by chance in our case, if we provide compression reinforcement, then it should also pass the maximum area limit. There is no limit for the minimum area, but the maximum area of compression reinforcement shall not exceed 0.04 times of BD. And they shall be enclosed by stirrups for effective lateral restraints. Similarly, the next requirement is the provision of side face reinforcement. Now, what is side face reinforcement? That we will see here. So, side face reinforcements are generally provided when the depth of beam exceeds. So, then we provide side face reinforcement on the sides also. So, if we provide reinforcement here, we also need to provide on the other face also. So, we provide equal reinforcement on both faces. If we provide two reinforcement at this face, we have to provide two reinforcement at this face also. So that is the basic requirement. So generally, in general beam, which are subjected to bending moment and shear force only, in that case, if the depth of beam exceeds 750 mm, then we are supposed to provide side face reinforcement. But here we are talking about the beams which are subjected to torsion along with the bending moment and shear force. So in that case, the depth limit is decreased, and that depth limit is 450. Sorry. So in that case, when the beam depth exceeds 450, then we have to provide side face reinforcement. So for general beam, it is 750 mm limit, but for the beam subjected to torsion, the limit is 450 mm. So if the depth of beam exceeds 450 mm, we have to provide side face reinforcement. Now, how much area of reinforcement there will be in the form of side face reinforcement? So that is also recommended by the IS code. So as per this clause, it says that the total area of side face reinforcement shall be at least 0.1% of the web area. Web area is basically the cross-sectional area. Web area, and shall be distributed equally on two faces at a spacing not exceeding 300 mm or web thickness, whichever is less. So if we are providing side face reinforcement like this, so the spacing should be less than or equals to 300 mm or this value, which is the web thickness, whichever is less. So generally we will be having reinforcement here, we will be having reinforcement here, and if we provide reinforcement here, so then we will see if this spacing should not exceed 300 or the web or the width of beam. So that we will see in our design example when we'll be solving that. Now, after that, we will see the distribution or the spacing of torsional reinforcement. Now, spacing of torsional reinforcement, we will be talking about the transverse reinforcement, that is the stirrups. So what should be the limit of stirrups that we will see here, and it is being given in this clause. So again, as I said, the code specifies maximum limits to the spacing SV of the stirrups provided as torsional reinforcement. So it says that SV spacing of the stirrups should be less than or equals to x1 plus y1 by 4 or 300 mm, whichever is less. We will take that. So first we will calculate the spacing and then we compare that spacing with these three values. And then we will take the value of spacing whichever will be the lesser one. Now here there are some terms. What is x1, what is y1? So here you can see distance, vertical distance between the center to center of the stirrups, it is y1. So you can see there is some difference between d1 and y1. d1 is the center to center distance of the longitudinal bar, and y1 is the center to center distance, vertical center to center distance of the stirrups. Similarly, b1 is the center to center distance of longitudinal bar in horizontal plane, and x1 is the horizontal center to center distance of the stirrups. So here we will be calculating the value of x1 and y1. Now also, so this is the A part of code. In the B part of this clause, it recommends that longitudinal reinforcement shall be placed as close as practicable to the corners of beam cross section, and in all cases there shall be at least one longitudinal bar. So it is saying actually that in all the corners we have to provide reinforcement as close as to the corner. Why we are recommending this? Because the warping of the corner will occur because of the torsion. So to avoid that warping, we provide reinforcement near the corner as much as possible. And also there shall be at least one bar at the corner. So as you can see, this beam is having 4 corner. So at least one bar at each corner should be there. So that is what IS code has recommended in this clause. So that is also we will follow. Now in the next part, we will take an example. We will solve an example to understand these process. Thank you.